Hey everybody, and welcome to another video. My name is Elric, and in this video we are going to be looking at a view inside of AdventureWorks 2017 and try to create indexes to make it more performant. Now this is a multi-part video because we're going to be using statistics.io, and I'm going to show you how to create covering indexes, but in the next video we're going to try to reduce our scan counts and figure out why these scans are happening. So I hope you enjoy, and I will see you soon. Alrighty, so we're going to be looking at human resources via employee. And what I normally do to start tuning something, contract, consultant, actual at my job, doesn't matter. I start with views because views are heavily used. So we want to make sure the view is performant before we look at the actual code. So I script the view as alter, and I find something that I see all the time from join. Like this is, what people do. So I will take the innards of this view and I will move it to two separate query windows. So I'll copy this, close it down. I'll paste it here where one of my windows has set statistics.io on with original at the top, and the other one doesn't have original. Because what we want to do when we're optimizing is we want to make sure we include the actual execution plan, which can get very horrible when we're doing it on procedures that call other procedures that go down the line. So we have to kind of choose between estimated and actual, but to get statistics.io and the plan at the same time, I'm using actual. I have statistics.io on here, off at the bottom, and then we'll run it. So I get the data back, 290 rows, and I get my statistics.io. What are my scans and what are my reads? And I'll get the actual execution plan. Now, scans are not bad all the time. We are primarily looking at how to decrease these numbers. We want to decrease these numbers because it's going to look at less rows and return them faster. It's going to know exactly what we're talking about versus trying to figure out what we're talking about. So that's kind of where the execution plan comes into play, where we're going to pay attention to, number of rows read, actual number of rows, operator cost. There's no range that you should be in. There's nothing that I can tell you that says, oh, we're trying to approach, 1 actually, but in one-to-many joins, we're never going to hit 1. So it's basically like, here's our starting metrics, and we're going to do something and compare them for where we are at now to see have we made an improvement? And the answer should be yes, we have. So covering indexes are the easiest way to improve your query's performance. Covering indexes really do depend on the model, and they do depend on the physical layer. They are part of the physical layer and the code. So how to create a covering index is basically you create an index on your where statement and you include your select statement. So in joins, sometimes it can be hard to read, trying to figure out how do we do that? Where's our where clauses? What are we actually including, et cetera, et cetera. So I use applies instead. And that's what this tab has. And I want to show you my technique, what I do. So we have inner join and left join here. And like I said in the intro video, knowing a lot of syntax is where you will get your optimization strengths from. So in here I have inner join, open parentheses. I'm going to convert this to a subquery, select star from that table. I'm going to turn my on to a where. I'm going to close off my join and give it the same alias that I see. Now you can see that it's saying, hey, I don't know where business entity is. And that is because inner joins don't allow you to do this. They don't allow you to pass columns from above down into your select statement. But cross supply does. So cross supply is like an inner join, and outer apply is like a left join. Same thing. Select star from, close it off, give it the same alias. Turn on into where, close it off, give it the same alias. So this code should run the same. It might have a different execution plan, but it will return the same results. From there, I figure out what columns are actually being called using the alias. So I'll go through this list. I see them over here in other join statements, and I have quite a few of them up here. So I'm just going to undo all the work I've done because I have one already completed. In the end, it looks like this. Cross apply, we select only the things that we need, from where, cross apply, from where, outer apply, etc., etc. So then I use this to easily create my covering indexes, which I have all right here. And I'm going to show you the pattern in how I create it. So I'll just use these two tables. I will go through this entire list and find the table name, copy it, paste it, find the next table name, copy it, paste it, etc., etc. I will use column select to write on multiple lines to create my parentheses. And I will go through again, find the select statement, put it in here, find the select statement, put it in here, come back down, use my column select again, parentheses, space, include, because we're including our selects, and this is what we're actually indexing on. So I will go through the list again and find my where clause. Finally, I get to use column select, create non-clustered index ix name on my table for this column, include these columns. So that's basically how I create covering indexes as quickly as possible. You want to optimize what you do, but also optimize the system. So just little tips, shortcuts that I do. Normally, I would go figure out what's already on the tables, so I'm not overwriting or creating unnecessary indexes, but this is AdventureWorks, and this is not really an example database. This is just a database with stuff in it. So I'm going to execute, create all of my indexes, my covering indexes, and then we're going to run our second item, our how are we doing item. Include actual execution plan is on, set statistics IO is on, and we're going to run it. So let's compare what we already have in the messages tab and see if we have made any progress just by doing our covering indexes blindly. So we can still see that our scans still exist. I'll be covering this in the next video because this has to do with the clustered index. But if we look at our logical reads, a reduction of 2. 2 is not much, even if you think about it, and you're calling this 1,000 times, 2,000, it's really not much in the grand scheme of things. But if we keep going down, we see a person had a logical read count of 897, but over here we reduce it to 607. So we're looking at a 290 decrease over 1,000 is 290,000 logical reads just from this basic, application of covering indexes. If we go to, we got to find person first in the execution plan, email, phone number, person phone, country, region, state, address, person. It should be the same. There we go. So if we're looking at person, our cost has decreased. Stop doing that. 6% compared to 19%. Honestly, we kind of want all of our tables to be in the same percentage range because that, tells you, hey, these are equally being, queried, scanned, seek, etc. it's more equal. So we do have a decrease. That means somewhere else in the system has increased the table. So that's pretty good. But we want to look at our rows read, actual number of rows, and our operator cost. So we have 290, 290, one execution, one row return, one number of estimated rows to return. Operator cost 0492. Over here, we said 0492 for our operator cost. Here is 0.212. So we already have this pretty, large decrease in the operation of what we are doing. But we still have the same number of rows read, actual number of rows, et cetera, et cetera. So we have decreased the operation, at least, of what SQL is trying to do, or what we're telling SQL to do, just in those few moments of going through, reorganizing the query, and applying covering indexes. So we do have some increase just from that. Now, to not necessarily get rid of all the scans, but to decrease these scans, we're going to have to look at the covering index. And I want to separate that out into another video, because talking about the clustered index itself, it takes a little visual explanation to figure out what is actually going on. So I hope you enjoyed, learned about covering indexes, some pretty nifty shortcuts to actually apply them. But do not stop here. There's a lot to cover on optimization. So I will see you in the next video. Like, comment, subscribe. Good luck and have fun.